Okay. You can go to your section, course content, and click on lab manual. Okay. Now, this week we will be doing lab 2, that is U substitution, right? Now, after you open your lab 2 manual, I want you all to look at the questions carefully, because this lab, we are not going to use MATLAB at all. Okay, so this lab is going to be done only on the paper. So you will be working out these problems by hand. Got it? So you will be doing integration through your hand. So it's complete handwork, and you're not supposed to use the MATLAB. You can use MATLAB to verify your answers, but I do not accept the MATLAB work for this, only for this lab. Okay, fine. Now, so I want you all to look at all these 19 questions. Fine. So just look at the questions carefully, and I will be doing, let's say 5 questions. Okay. I will do any 5 questions that you choose.
It's gonna suck, Jack. Lost.
Make sure your thing's not on.
It's not. Look. Oh.
So just select any 5 questions that you want me to work, so I can show you how the method is used. Okay, you can drop all your questions in the chat box. I can note down the questions, and then I will start working out these problems. So students in class, do you want me to do any specific problems among these?
Yes, that would be nice, actually.
Yeah.
Could you do number 1?
Okay, number 1, and okay, I will get started, and meanwhile you can think of the problems. Okay, let me open the Blackboard. Okay, so lab 2, U substitution. So I will do 5 examples. I mean 5 of those problems, and you are supposed to do the rest of the problem. Now, this is how it will work. You can stay on Zoom, or you can stay in the class until you finish your homework. And if you have any questions, I can help you throughout the lab. Okay. And if you have questions on lab 1, because the lab 1 is due today before midnight, if you have questions on those, you can stay on Zoom, and I will take up your questions on lab 1 after I complete lab 2. Okay. Fine. So I will do first problem, and the question is integration of sine of cos x into sine of x. This is the question 1. Okay. Now let us see how we solve this using U substitution. Now first one. Now remember, you have to select your U in such a way that you will not face any X terms in this problem. Okay. I will show you how it will work. Now I will choose U as cos of X. Let me write the steps here. Okay, so when it comes to U substitution, first thing is you change everything in terms of U. Okay, that's the main concept here. And then you solve the integral. Now, why can't I solve the integral directly? Why can't I do this? That's because you have a composite function, right? You have the trigonometric function and it is composite. If you have something like this, sine of x, you can always solve this. This will be minus cos of x plus c, right? What if I have, instead of x, what if I have cos of x? Right? So what do you do when you have this type of problem? We use U substitution. So let me do this simple example. What I do is I will substitute this as U, okay, single term. Then my integral will change to sine of U. Now do the integration. That becomes minus cos of U, right? Plus C. Now you can substitute this back in the equation. Now your integral is solved. So this is how the U substitution will work. Okay. Now, coming back to the first example. Now I have chosen cos of x because that is inside the sine function. So if I make this as one variable, then I can solve it easily, right? Okay. Now, finding the derivative. Why should I find the derivative now? Because this is the integral problem. Then why am I supposed to find the derivative of u? That's because I want to change the dx as well. Because remember, the first step is to change everything in terms of u. I need everything in terms of u. So I have to change the dx. How can I change this? Only when I take a derivative, I will get this term dx, and then I can simplify this, solve for dx. I will get one equation which is entirely in terms of u. Okay, that's the plan. Okay, now derivative of cos x is going to be negative sine of x, right? Now I need to solve for dx, remember? Now you're going to send the dx to the numerator on the other side. Then what happens to sine of x? This comes to the denominator, right? Exchanging. So this becomes minus du divided by sine of x. Got it? Any questions till now? Do you want me to repeat this? Okay. Now, after doing this, after doing the u substitution, now coming back to the problem. This is the main problem now. Integration sine of cos of x, right, into sine of x into dx. Now we know that I have substituted u as cos x. That means you are going to write u wherever you have cos x. Okay, so I have sin x, but I do not have any substitution for sin x, so I will keep it as it is. But I have derived what is dx here, so I will substitute what is dx minus du by sin of x. Now look here carefully, because you can eliminate sin of x, sin of x, sin of x. Cancel. Okay. Now that is the reason I took u as cos of x. You can also take it as sin of x. Okay. Remember, choose u in such a way that the another term or the other or extra term cancels out, like it is happening here. Fine. So you have to choose u or select u carefully. If you have like composite function, if you have sine of cos of x or cos of x inside sine of x, then remember to choose anything which is inside. So that you can easily solve it, right? Because if you take it as sine x here, okay, so if you take u as sine of x, then this becomes u of cos of x. Okay, then you might feel difficult or hard to solve the integral. So remember, you have to choose u carefully in such a way that the other term, whichever is there, cancels out. Okay, fine. Now let us get back to the problem. Now we know that this cancels out, then what is left out? The left out term is sine of u. We have negative, do not forget that, and then du. Agree? Okay. Now, can you solve this integral? Yes, I can, because it is only one term. So integral of sine of u will be minus cos of u, right? Minus cos of u. But I also have minus outside, so I will write double minus plus c. Yes, minus cos, which becomes plus cos. Now, this becomes plus cos of u plus c. Remember, you have to write the constant, integral constant, or else you will be losing your marks. Okay? Remember to write the constant when you remove the integral. Why should I write the integral constant? That's because I do not have any limits in the integral. Okay? Remember, what is integral and why do we have to do that? Integral is nothing but the concept is to find the area under the curve. Okay? Integrating means summing up. You sum up everything here and then you find the area under the curve, right? So when you have limits like this, that means you know that I have to find area from this point to this point, right? It is so simple that you are supposed to find this area. What if I do not have a limits? What do you do then? If I don't tell you from which point to which point you are supposed to find the area, then what do? Then you might see that you will not get a definite number, right? You will not get a definite number. And that's the reason we introduce this constant. Okay? Okay. So remember to write integral constant once you remove the integral sign. Okay. Now, what is the final answer now? So I will write the question again. Sine of cos of x into sine of x dx equal to cos of, now you are going to substitute this back. Okay, you are going to substitute u as cos of x in the final answer. Cos of x plus c. Okay, so that's your answer. Fine. Now this is not the end. Come back to the lab manual. Now these are the questions which you are supposed to solve. These are not the questions, okay? These are the questions which you are supposed to solve. Now on the other side, you see that these are the solutions. And you have also words, right? Okay. Now for the first problem, we got answer as cos of x, right? Now search for that answer in this column. Where is it? Okay, it's here. So this is the answer for first problem. Now, what is the word which is associated with that? It is and, right? Now remember that, and come back to the problem here. You have a blank space given here, right? Now you're supposed to fill that word in this blank. Got it? Now you're not supposed to stop there. You still have one more thing to do. That is scroll down and come to the end. Now here you have question number given randomly, right? After a blank. Now choose or select which question were you solving. It was number 1. So here you are going to write that word. And got it? I know it's slight confusing. I'll repeat it again. Now, once you solve the integration, you will get your answer, right? Come back to the lab manual. This is your solution column. You have to search for that solution and match it in the solution column. We did that, right? Once you do that, you're going to copy the word which is next to that and write it next to the problem. Fine. After you do that, just fill everything for the first time. So you're going to fill this first and then come back or scroll down. Here you're going to fill everything with words. Okay. Now, once you fill up this blank, you will get a statement, or let's say a message. Okay, that's where you're going to end. So remember, when you complete this lab, you're going to merge 2 documents. I need this document as well as this document. This is very important. I need the hand calculations. Okay, you're not supposed to fill only this document and upload. You're going to upload your hand calculations as well. Okay, both are quite important. You need to write your name, your section, and date. Fill this column, fill this blanks, upload this document along with your hand calculations. Okay, got it? Okay, so I have completed problem number 1. Is there any questions you want me to do? Okay, I can do number 10. Do you have any other questions? Sure. We will do question number 10. Okay, that's a good question. Tan of x secant to the power of 4 into x dx. And this is the integral. Okay. Now, before I do the U substitution, you can do one thing. You can minimize this. Okay. We have higher power, so we can bring down this to secant square. And then we can do U substitution, then solve it. Okay, that's one method. Or if you want to do U substitution without simplifying, that is also fine, but you might have to solve with extra number of steps. Okay, fine. Now, remember we have this identity. If you have studied, remember this identity, secant square of x equal to tan square of x plus 1. Okay, now I'm going to use this identity to solve this problem. I will just put this in the blank. Okay, now I will keep this as it is, tan of x. Now I have secant to the power of 4, right? Now I can divide it as secant square x into secant square x into dx. Okay, now we are going to substitute the formula. Now I will just write this as same thing. Now this secant square x is tan square x plus 1, right, into dx. Agree? Now what can I do? I will keep the secant square of x as it is, and I will multiply tan of x to both the terms. When you do that, okay, so square root of tan of x is nothing but tan of x to the power of half, right? Multiplied with tan square x. Okay, this multiplied with tan square x. That will give you tan to the power of half plus 2. That becomes 5 over 2, right? You're going to add the powers, okay? This becomes 5 over 2 to the x plus square root of tan of x, because you're multiplying this with 1, so it becomes tan of x. Now, let me erase this and write the answer. So this is tan 5 over 2 x plus tan of x square root into dx. Okay, now you have simplified. Now you can substitute. Okay, let's see. I will take u as tan of x because I have tan of x. I would like to take this as u, then solve it, or else you can think it of like if I take u as tan of x, then its derivative is secant square x, right? So that I can cancel this secant square x as well. So I can take u as tan of x, right? So now find the derivative. So we know that tan of x derivative is secant square of x, right? Okay, once you do that, you are going to find what is dx. How? Just exchange the numerator with denominator. So this becomes secant square of x. Okay, done? Okay, now coming back to the problem. The problem was tan of x, square root of tan of x, or I can take this, okay, equal to integration of secant square of x, right? Because I did not substitute anything for secant square of x, so I will write it as it is, big bracket. Now we know that tan of x was u, right? So u to the power of 5 by 2 plus square root of u, I can write it as half. Okay, into what is dx? Dx is du divided by secant square of x. Okay, now you can see that the secant square of x in the numerator and in the denominator is cancelled, and you will get integral of u to the power of 5 by 2 plus u to the power of half into Okay. Good. Now find the integral separately. You will get u 5/2 du plus integral u half into du. Find the integral here. This becomes integral of, remember you have a power rule, right? Integration of x to the power of n is n x to the power of n plus 1 divided by n plus 1. Okay. Now using the same formula here, you get u to the power of 7/2 plus u to the power of 3/2, 2/3. Why did I get 2/3 here? I will show you one power rule. Now we know that this is half plus 1. This becomes half plus 1, right? So this is u. This becomes 3/2. When you add half plus 1, that is 3/2 divided by, again, 3/2, right? Now you need to bring this to the numerator. So this becomes 2 times 3/2 divided by 3. That's how you get this. Okay. Just erase this so that I can make some space. Okay. Plus c, because I removed the integral, so writing it as plus c. 2/7 tan of x, right? That was our first substitution, 7/2 plus 2/3 tan of x to the power of 3/2 plus c. That's your answer. Okay. I will give you a minute to write this. Okay. Now let us come back here. Which problem did we do? It was 10th problem. 10th problem, and the answer was tan of x to the power of 7/2. Okay, it's here. Okay, so your solution is here. For 10th problem, you have solution here. What is the word associated with that, or next to that? It is from. So I will write from here. Okay, likewise, you're going to fill all this blank, and remember at the end you will get a message. You have to get that message. Okay, any other questions? You have 3 more to ask. Okay. Let us do 19th problem. Of x to the power of 5/4 square of x into dx. Okay. As usual, we will take u as tan of x because we need secant square of x to be eliminated. Okay, and that's the reason I took u as tan of x. Du by dx equal to secant square of x. Okay. Now what are we supposed to do? We are going to exchange the numerator and denominator. So that will give you dx as du divided by secant square of x. Okay. Now, you are done with the u substitution. Come back to the problem here. This will be equal to, we know that tan of x is u, right? So u to the power of 5 by 4. What is secant square of x? You don't know yet because you have not substituted that with anything. Okay. So you will write it as it is with d of x. So what is d of x? This one. So d of x is du divided by secant square of x. Okay. Now you can see that these two get cancelled out, and then we can solve u to the power of 5 by 4 into du. Okay. Again, you're going to use the same power rule. I can elaborate the answer if you want. So using the power rule, u 5 by 4 plus 1 divided by 5 by 4 plus 1. So this will give you u to the power of 9 by 4 divided by 9 by 4. So you can reciprocal this. So that will give you 4 by 9 u to the power of 9 by 4. Remember, you have to put the constant c. Okay. Now finally, you will substitute this u with tan of x to the power of 9 by 4 plus c. Now, if you have confusion, because when I was learning my calculus, I had this confusion. So remember, for example, if you have tan square of x, this is nothing but tan of x the whole square. Okay, you can write like this as well, but this is not similar to tan x square. Okay, do not make this mistake. So you can write this in either way, but you cannot write in this way. Okay, so this is completely different. This is completely different. Now remember, if you have something like this, and if you want to take a derivative of this, then you will have to do chain rule. Okay, what if you have tan x the whole square? That is completely different. Okay, so remember, do not make this mistake. Even while you write your solutions, you have to be careful. Okay, so this is your 19th question. Any other
I have a
question?
question.
Yeah.
So what happened to the du like after you I took the antiderivative?
This one? Or are you asking about the integral part?
Yeah, like so yeah, like that part right there.
Okay.
What happens to the du?
So when you solve u to the power of 5 by half, this integral and this will get cancelled. Okay, so when you solve the integral, when you use the formula, when you remove the integral part, this goes with it. So you are not supposed to write du with this. Okay, and that's the reason we write c here.
Okay, got it. Thank you.
Okay, so when you have integral, remember dx has to be there. Dx or du, whichever is your variable, this has to be there. This is mandatory. When you remove the integral, if that is indefinite integral, if you're solving that type of problem, when you remove the integral, you have to introduce a constant. These are the main rules you will have. Okay, do not make this mistake because one of your lecture instructor emailed me saying that if the students make this mistake, they want me to deduct more points. So I do not want to take off the points. So remember to follow these rules. When you have integral sign, you have to have this as well. When you remove the integral sign, you must have the constant c. This is only for indefinite integral. Okay, very important. Okay, any other questions? I think you have two options, two choices.
Number 17.
17. Okay. Problem 17. Integral e to the power of cos of x into sin of x dx. Okay. Now, what can I take as u? Anyone? What was the answer? Cosine of x. Any other answers? Okay. So we have to take u as cos of x. That's because when you take a derivative, you will get sin of x. Then can I not take u as sin of x because I will get derivative of cos of x? Yes, you can take u as sin of x. Then what happens to derivative? That becomes du by dx, which gives you cos of x, right? I agree with that. But remember, when you substitute this back here, I want that cos of x to be cancelled. Can you cancel cos of x if you substitute this back here? You cannot, because remember that becomes like, let me show you how it looks like. If you choose sin of x, then that becomes du by cos of x. Okay, you cannot cancel these two terms, right? You cannot do this. You will have cos of x in the power. Okay, and that's the reason we take u as cos of x. Okay, this is how you have to choose the u. Okay, now we will find the derivative. That becomes minus sin of x. Now we are going to interchange numerator with denominator. Dx will be du negative sin of x. Okay, now coming back here, substitute here, this becomes u to e to the power of u. Then what is sin of x? We will keep it as it is into minus du by sin of x. Okay, now we can eliminate the numerator and the denominator. Now I will write this as, I will keep negative outside, e to the power of u du. Okay, now what is integral of e to the power of u? E to the u, right? Is e to the power of u. And what should I include along with this? Negative and yes, and the constant c. So when you remove the integral sign, that means when you apply the integral formula, du will be changed as c. Okay, remember in that way. Okay, now the final step is to substitute the u back. That becomes cos of x plus c. Okay, that's your 17th answer. So do you have any other questions? You have one last choice. You can choose any one problem. Okay, number 12. Question number 12, it is cosecant cube of x, cot of x into dx. Okay. Now I will take u as cosecant cube x. Okay, because it has the highest power. If I minimize this, then I can easily solve the integral. Okay, now finding the derivative of du by dx. When you have cosecant cube x, that becomes minus c times cosecant of x square. Okay, remember this is like a chain rule. You have x cube as well as x. You have power rule with the variable. Okay, you're going to apply chain rule. Got it? So first you are going to apply the power rule, and then you are going to find the derivative of d by dx of cosecant x. Okay, now when I apply the formula power rule, x to the power of n derivative, that becomes nx to the power of n minus 1. Right, that's the formula for derivative of x to the power of n. Okay. Now, that is what I'm doing here. Now I use the power rule. This is done. Now I'm going to write the derivative of cosecant x alone. Okay, you can think it of like cosecant of x, the whole cube. First, you're going to find the derivative for this cube and then for cosecant of x. Okay. Now, what is the derivative for cosecant of x? That is going to be minus cosecant of x into cot of x. Okay. First is we are going to find what is d by dx of cosecant of x, the whole cube. That will give you 3 cosecant of x, the whole square, because 3 minus 1 is 2, right? N minus 1. Okay. Now, once you solve the power rule, you have cosecant x left out. So that will give you negative cosecant of x with cot x. That's the formula for cosecant of x. Okay. Now, du by dx will be negative 3. Now you can easily multiply these two, right? You have same base. 2 plus 1 is 3. So cosecant cube of x into cot of x. Okay. Now what is the next step? You are going to change the numerator and the denominator. So this becomes du, negative du, divided by 3 cosecant cube of x into cot of x. Okay, done. Now you're going to apply this in the problem. So cosecant cube of x is u and cot of x. I do not have anything for cot of x. Now this is minus du divided by 3 cosecant cube of x into cot of x. Okay, now this is u cube. Okay, now what can we do? Because I can cancel out cot of x and cot of x. But what can I do with cosecant cube of x? We know that we have substituted it as u, right? So this u and this u cancels out. I will do that in the next step. So we know that cot of x here and here it gets cancelled, right? Now the remaining term is u. We pull the negative out. Du divided by 3 times cosecant cube of x is nothing but u, right? We substituted that in the first place. Okay. Now what happens? These two get cancelled, and what do you get as final answer? Final integral, you get it as negative 1 over 3. You can keep it inside or outside. That doesn't matter. Okay, into du. Got it? Now, what is the integral of a constant? That is going to be negative u. Since we have 1 over 3, I'll keep the 1 over 3 in the denominator. Now, the du is gone. It is replaced with plus c, integral constant. Now, the final answer will be minus u is cosecant cube of x, right? Divided by 3 plus c. That's your final answer. So I have completed all 5 examples. Now it's your work to complete the rest of the problems. So if you want to complete your assignment today, I mean, right now, you can do it. And if you have any questions, I will be on the Zoom. So you can also stay on the Zoom and ask me questions if you have. Okay. If you do not wish to ask in front of everyone, or if you do not like to show your answers to everyone, then you can just text me, or like you have a chat option there. You can select my name and send me a message privately so that I can give you another window where only you and me can chat. Okay, you have that option as well. So if the students who do not need any help, or if you have no questions, you are good to leave. So this will be the end of lab 2. Okay. If you want me to show any examples which I have done here, you can tell me. I can scroll up or down. Try to attend in-person labs so that You can finish your assignment on the same day and upload it so that you do not have to worry for a week.